Hello everyone, welcome back to Physics 11. So I wanted to go over some of the homework questions that people asked me from section 5.1. Now you can just look at the worksheet solution. If you just click on this, it will show you the solution that I already done in the past. You can also click here and download the copy. Okay, so make sure if you download to your own computer or phone or whatever you're working on, if you want to modify it in some way. Now I'm going to be working through these questions, and the solutions you can also look at in the notes section here. So there's going to be basically a page from OneNote where I uploaded the same worksheet without any solutions. So I'm going to be working from there. So here we are. Question number 4 is one of the questions people asked me to go over. So this says calculate the gravitational force on an object that's this heavy and that is this distance away from the surface of the Earth. So it's really important in this question to understand that you're not on the surface of the Earth. You cannot use just Fg equals m times g. We have to use the universal gravitational law in order to find the force of gravity. Now, the real important part here is to find the actual distance away from the center of the Earth, from the center of mass of Earth, to the object, which means we need to add the radius of the Earth and the distance above the surface. So the radius of the Earth is, I listed it here. Now, if you maybe use slightly different value for it, you might have maybe slightly different answer compared to the answer key. So just keep that in mind. Also, if you maybe made some rounding mistakes when you were doing this, you might also get a wrong answer. So again, be careful with the numbers, double check your math. In this case, let's add the two numbers together. So we have the distance from the surface, 4.15. This is raised to 10 to the 6th, plus the radius of the Earth, which is 6.38, exponent 10 to the 6th as well. So we're going to get our R value here of 10,530, and then 3 zeros. Now this is not rounded right now, this is the actual value, but you have to keep track of sig figs. So I have 3 sig figs here, three sig figs there. So here I actually only have 3 sig figs. Now in the calculations I'm going to use this entire number because I don't want to get rounding errors, but I will keep in mind that that number should be rounded to 3 sig figs when I have to round my final answer. So that's a common reason for some discrepancies or differences in the final answer, because people are rounding when they're not supposed to be rounding. So I wrote the equation already here, so all we have to do is plug in the values for our masses and our distance away. So we have 6.67 times 10 to negative 11 for constant, gravitational constant, mass of the Earth. Again, depending what value you use for the mass of the Earth, you might get slightly different answers. This is the mass of the object. Don't forget to square this, your radius. When you do the math here, let's see, 6.67 raised to negative 11 times 5.98 times 6.5 divided by 10. All right, so here's, oh, I forgot to square it. Let me double check this. Don't forget to square your R. Re-enter this again. Again, there's a lot of numbers here with a lot of exponents, so there's a lot of room for mistakes. So again, if you stuck because you're not getting the right answer, double check that you do not miss any of the exponents. So here's what I got. I got 2,338.9 3.2 newtons. Now I know that I have 3 sig figs here, and this should be 3 sig figs as well, right? So my final answer should be rounded to 3 sig figs. So basically up to here, which means we have to round this up to 2,340 newtons. So now that's 3 sig figs. So that's question number 4. The next question people asked me for was number 5. Now in this case, it says gravitational force between two objects is given to us. So we have the Fg, and we're given the distance apart. So we have the r. It says if the mass of one object is 55, so we had the value for m1. What is the mass of the other object? So basically we had to manipulate the equation, solve for m2 first, plug in all the values that were given, right, to find the one unknown here. So m2 is the unknown. Take your equation, rearrange it for m2, which means we need to first multiply both sides by r squared, so we're going to get this. So Fg times r squared. Okay, and then divide both sides by g times m1 to get rid of g and m1 on the right side to get the m squared by itself. So here's what we're going to get. We're going to get r Fg r squared over this equal to m2. Once you get to this point, all you have to do now is plug in the numbers to get the answer for m2. So let me write it down here. So again, my Fg here is 3.2, 10 negative 6. R squared, again, don't forget to square the r. So 2.1 times 10 to negative 1 squared over 6.67 times 10 negative 11, and m1 is 55 kilograms. So 2 sig figs, 2 sig figs. So it looks like our final answer should be rounded to 2 significant figures. So let's see what we get. 3.2 raised to negative 6 times 121 squared. Now when I do the division here, I'm going to put the bottom two numbers in brackets just in case my calculator doesn't understand what I'm wanted from it. Times 55, close the bracket, I get 38.146 kilograms. All right, now I need to round this. So because we have 2 sig figs, we need to round this to basically just 38. So that's question number 5. Now the last question people asked me for was number 11. So number 11, let's read this out first. So I have 3 objects, A, B, and C. Okay, they're placed 50 centimeters apart, so that's 0.05 meters along a straight line. So basically, I don't know what they're placed on, but they're the same distance apart of 0.5 meters. It says A, B have mass of 10 kilograms, while C has a mass of 15 kilograms. What is the net force on B, so the object in the middle, and then we're going to have object A exerting force of attraction and object C exerting force of attraction on the object in the middle. So the question says, what is the net force? So in order to solve this question, you had to have a free body diagram. Now I didn't do a separate free body diagram. All I've done is just added a couple of vector forces here just so we see what we're dealing with here. Now we only care about object B, the object in the middle. So there's going to be 2 forces pulling on this. C is going to pull it toward itself, and then A is going to pull it to the left. So I labeled the 2 vectors, force AB and then force CB. So I explain what this is. So force AB means A acting on B, force CB means C acting on B. So B is the one that's going to be pulled left and right here by different forces. So basically our F net equation in the x direction, we only care about the x direction even though they might be sitting on a hard surface. So there might be normal forces and force of gravity acting on it. But again, we only care about the x direction. So the y axis Like I said, this is not a proper free body diagram. I just labeled the two forces acting out along the x-axis. So the F net is going to be the two forces. So notice here I made my positive to the right, which makes the FAB negative. And then, I don't know what happened there. So FAB and FCB is positive. So that's what we're trying to find. Now, in addition, if I were to modify this question a little bit, I could also ask you to find what is the acceleration due to the forces acting on object B. So I could also ask, well, what is the actual A value here? Because you know the mass of B, and once you know the left side of this equation, you can actually find the acceleration as well. So that'll be maybe like part B that I could ask you on a question like this. Now in this case, we just need to find the sum of these two forces. So we have to actually use the universal gravitational law to find this, because again, that's the equation that works for any configuration of objects that have to be on the surface of the Earth, like just the m times g. So what we need to do is find these two separate forces and then add them together. Now when we're going to do that, we're just going to find the magnitudes of them. So let's do force AB, and then we can make it negative later if we need to when we do the net force. So remember this sigma fx, this means sum of forces or F net. So people still may be a little confused about notations. This is the same as saying F net in the x direction, or just write sigma fx. So this is my preferred way to state the F net, or the sum of forces. So in this case, let's see. What we're gonna need is our gravitational constant, so we're dealing with A and B, so we're gonna have to deal with mass A, mass B, and the distance r between A and B. Okay, so I listed them on the side here, or you can just read them from the question. So let's plug in the numbers. Times 10, negative 11. So I think in the solution that's already posted, I skip over this step. I just show you the answer, but basically because it's so repetitive and there's not a lot of room here, that's why it's not included. So in this case, let's actually do every step. So let's see what we get. Our mass A is 10. Our mass B is 10 as well. All right, and don't forget to score the R here. And then RAB is going to be converted to meters, so don't forget to convert it to meters. So 0.5 meters. Now in this case we have 3 sig figs here. All right, so all the numbers for the mass is 3 sig figs, 3 sig figs, R is 3 sig figs, so the final answer should be rounded to 3 sig figs as well. So let's see what we get. 6.67 exponent negative 11 times 10 times 10, then divided by 0.5 squared. We get this number, 2.668 times 10 to negative 8 newtons. Again, we know that this has to be rounded to 3 sig figs, but I'll keep the whole number to find my F net and round it afterwards. So let's do the next one. Let's do the force CB. So again, we're dealing with mass B and mass C. So we have our C, B, and I call this BC here, squared. So 6.67. So mass C now is 15 kilograms, 15.0, and B is 10. So the force should be slightly bigger than the other one. The distance apart is still the same. So 6.67 raised to negative 11 times 15 times 10, then divide by 0.5 squared. So I got 4.002 times 10 to the negative 8 newtons. All right, so again, gotta remember that this is gonna be rounded to 3 sig figs here. All right, so we found our two forces. Now we can find our F net, so we can complete this step right there. So we can do our F net, which is just adding the two forces. Now, I already wrote the equation here, so I'm gonna make my AB force negative. So I'm gonna stick a negative in front of this. 2.668 times 10 negative 8 plus 4.002 times 10 negative 8. Again, least number of decimals when you add, but then we still need to round this. So let's see what we get for the net force. Minus 2.668 exponent. All right, so we get 1.334. All right, now because like I said, this is actually should be rounded to there, and this should be rounded to there. There's only 2 decimals here, 2 decimals there, so we should be rounding this to 2 decimals. So we're gonna end up with 3 sig figs here. So the final answer is gonna be 1.33 times 10 to negative 8 newtons. Okay. Now, for example, like I said, if I ask you to find the acceleration, once you know the force, the net force, right? So remember your F net was, let me rewrite the forces here, FAB plus FCB equals MA in the x direction. So again, we found this part right here. We found that this number is 1.33 times 10 to negative 8 equal to MA. Okay, so we know what M value is. We know that M is 10 kilograms. So I could ask you to find the acceleration, which in that case, it's just going to be taking the force, the F net, divide by the mass, right? So I could ask you, what is the acceleration due to the two objects pulling on the object in the middle? Well, it's going to be this number of newtons over the mass, which again is 10 kilograms. And you would get your acceleration. Now this is not what the question is asking us for, so this is just an aside here, okay? Because some questions may ask you to do that. So you can find the acceleration, and even more complex question would be to then use kinematics as well to maybe find the finite velocity or something like that. So that's a common question in dynamics when you have to find the acceleration and then use kinematics after. So anyway, those are the 3 questions people ask me for, so I'll post this again in the dynamics section. Make sure you check the answer sheet or answer key in the file section, and you can see these notes again under files.